If you would like more detail on how to graph transformations of the log function, I encourage you to watch the first video because I went into a lot of detail. That was a longer video. Here we see for this one, we're going to have a shift to the right 3 units and up 1. So right 3 units. We originally had our key point at 1, 0. And if we move to the right, we have 1, 2, 3, and up 1, 1. So our key point now, the coordinates of our key point are 4, 1. Because we've moved to the right, we also want to make sure we move our vertical asymptote to the right. And moving our vertical asymptote to the right, we're going to go ahead and draw that. It'll be easier to draw the graph because the graph looks exactly the same as log base 2 of x. Log base 2 of x comes up, goes through the key point. Always want to label the coordinates of the key point so I know. And then also you could either label your vertical asymptote here, x equals 3, or just make sure that the vertical asymptote doesn't go through the key point. Key point is never touching the asymptote. In fact, never do you have a vertical asymptote in which a point is touching, part of the graph is touching it. Domain, we could see, if you know what to look for here, we could see that all the x values have to be greater than that vertical asymptote. All the x values such that x is greater than 3. The range is always all real numbers. We could see that the function is increasing for all values of x greater than 3, decreasing nowhere. No horizontal asymptote, but we do have that vertical asymptote of x is equal to 3. The x-intercept, we'll go ahead and calculate that. We'll do that over here in the middle of this second quadrant. When we let let y equals 0, we get 0 equals the log base 2 of x minus 3 plus 1. We're going to go ahead and subtract 1 from both sides. And now that we have our variable locked up in our argument and we have a log on one side, number on the other, that means we're going to shift over to exponential form. 2 to the negative 1 is equal to x minus 3. We know that 2 to the negative 1 is 1/2. If we add 3 to 1/2, what do we get? 3 plus 1/2. So if we add 3 to both sides, 6/2 plus 1/2, that's 7/2. So 7/2 is equal to x. That's 3.5. So our x-intercept, we could see that that's a reasonable x-intercept to the right of our vertical asymptote, so we're good there. So again, our x-intercept is 7/2 or 3.5 comma 0. You can see it doesn't go through the y-axis. And again, we don't have a max or a min when we have a log function. Yes, 1-to-1, NA for slope, and none for the other. Vertex, no axis of symmetry either.